I'll take an example of a computer network and show you how does the actual things work in computer networks. Let's say you are in India and this is somewhere on one network, Airtel network in India, and this is your host. Host means your computer. See, this is the network. Let's assume this is the Airtel network in some region in India, and this is your host, and this is a process. Okay, process. So what is it? Network, and within the network there are many hosts, and one of the hosts is your computer, and the other one is within a host there are many processes, and one process is you have opened your web browser and you have typed say google.com. Now you want to go to Google and get a web page, and assume that Google's network is in California, somewhere in US, and this is the network in which Google is present. And now inside that network, one of the server is Google server, this is the host, and one of the process is the server which you want to connect, which means from your process at home you want to connect to the process of Google in order to get the web page, right? So what did you type in your web browser is www.google.com. Now when you type this that name, domain name, that domain name has to be converted in such a way that you are going to identify the network here. See, which means your request has to start from here and it has to first reach the destination network, isn't it? It has to reach the destination network, and after reaching the destination network your request has to reach the destination host within the network, and after reaching the destination host it has to reach the destination process, right? Therefore step 1 is your request has to reach the destination network, and step 2 is your request has to reach the destination host, and step 3 is your request has to reach the destination process. There are 3 steps involved in here, right? So in order to identify the network, the destination network and destination host, you have actually given only www.google.com, the domain name, right? So you gave only this www.google.com, and now using this name, this domain name, we have to identify the network and then the host and then the process, right? So somehow we have to convert this domain name into some numbers so that it can be identified. So there has to be a service which converts the domain name into IP address. Why IP address is, IP address will have 2 parts. One part is called network ID and other part is called host ID. Therefore using network ID we can reach the target network, and using host ID we can reach the target host. And then in order to reach the process we need something called as port number. Since you are talking about web service which is HTTP, all the web services will be run at port number 80, that is globally known. So everyone knows that if it is a web service it is 80. Therefore in order to reach the process the port number will be used, which is already predefined as a well-defined port, right? So this is how it happens. First thing is your domain name has to be converted into IP address, and your IP address is going to have 2 parts. One is network ID and other is host ID. Network ID is used to reach the network and host ID is used to reach the host. And then in order to reach the process we actually need the process number also, which is nothing but port number, and most of the port numbers are already predefined and they are fixed, right? And for the well-known services, since it is a well-known service it is fixed. If it is not a well-known service you should even know what is the port number at which the target server is running. For example, FTP it is 21, SMTP it is 25. So likewise we have all the for well-defined ports, for well-defined services we have well-defined port numbers. Now the step is, how are we going to convert this domain name into IP address? So in order to do that, see, one thing is, if you know the IP address directly you can contact the server, but then it is very difficult to remember the IP numbers, right? Because we are good with remembering the names rather than remembering the numbers. That is why your ISP, internet service provider, is supposed to provide you with a service called domain name service, which means inside your network itself it is supposed to configure a domain name server. So before actually contacting the Google, you will actually contact the domain name server and ask for the IP address of what is the IP address of google.com, and now DNS is going to return you the IP address of google.com. Once you get the IP address of google.com, you can directly reach it. Now this entire procedure, which is converting the domain name to IP address, is actually a overhead. See, we wanted to reach Google, we didn't want to reach DNS, but then we had to reach DNS because we want to convert it, right? Therefore this entire step is called DNS overhead. So what we generally do is, we don't go to DNS all the time. We generally do it for the first time, and then we save the IP address in our computer for some time, and whenever it has expired, generally we use a log for some time, and whenever it is expired, again we will go to the DNS. So first time when you are contacting any server, sometimes the service will be late because there is DNS overhead. Second time if you use the service, then it will be straightforward. Right. So one thing you should note is, the main important thing in this communication is IP address. So let's talk about IP address in detail, before talking about IP address, I want to talk even about the binary numbers. Okay, so we shall talk about binary numbers and then IP address now. Yeah, so now let's see about IP addresses. Before going to IP address, I want to talk about binary numbers a bit. So binary numbers are, this, right? Number system has evolved, and the first number system was unary, right? So what is unary number system is, we have only one symbol, which is nothing but 0. So this is the most popular number system, even you have used it in abacus long back in your childhood, right? So if I had to represent any number like 1, I represent it using 1 0. If I had to represent 2, I represent using 2 zeros. If I have to use 3, I know it is 3 zeros. So this is nothing but unary number system. And after that unary number system, the most popular number system is decimal number system. In decimal number system, we have 0, 1, 2, 3, so on 9, which means 10 symbols. And you are very much aware of it. Now the next number system which is popular is binary. Because of the invention of the computers, we have been using binary. In binary number system, the base is 2, and therefore the number of symbols we have is 0 and 1. So always remember, if the base is n, if the base of a number system is n, we have n symbols in the number system, and all the symbols will be starting from 0, 1, 2, 3, so on, n minus 1, right? And now the binary number system, we have 0, 1. And then we have hexa, octal number system, in which the base is 8, therefore the symbols are 0, 1, 2, 3, so on 7. And in hexadecimal number system, we have 16 symbols, but then since we have only 10 digits, 0, 1, 2, 3, so on 9, we have used A, B, C, D, so on F as the remaining 6, right? So these are 10 and then 6, that is why it is hexa. And now A represents 10, B represents 11, and F represents 15. Okay, so this is all about the number system. So we have all these number systems, but no, the most popular number system is binary coming to computer science. Therefore I would like to, I'd ask you to be very good with binary number system, especially the powers of 2's. And coming to this, you should have a grip over these numbers. So 2 power 1, 2 power 1, 2 power 2, 2 power 3, so on, 2 power 10. 2 power 10 is nothing but 1024, and sometimes it is also called as k. K represents 1024. Okay, and then m represents 2 power 20, g giga 2 power 30, t tera 2 power 40. So you should be very good with all these conventions, notations. What is m and what is g, what is t, especially in computer science it is going to be very important. And we shall talk more about binary numbers once. Let us say I have one binary bit. With one bit, how many numbers are possible? How many binary numbers are possible? Okay, so with one bit we can have two binary numbers, 0 and 1. If I have 2 bits, if I have 2 bits, how many binary numbers are possible? I can have 4 binary numbers, 0 0 0 1 1 0 1 1, which means 0 1 2 and 3. With 3 bits, how many binary numbers are possible? You know it is going to be 8, right? Why? I have 3 blank spaces and 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay, now this part you know it well. Now next thing is, if I choose one bit, how many parts will I be dividing the entire space into? Let us say this is called the address space or number space. With 2 bits this space contains 4 numbers, with 3 bits this space contains 8 numbers, right? So now my next question is, let us assume that we have such a space, and now if I choose one bit, let us say I am choosing the first bit. If I choose one bit, how many parts will I be dividing the entire space into? It turns out that we could divide this entire space into 2 parts, isn't it? If I choose one bit, I am dividing the entire space into 2 parts. One part contains all zeros in this selected bit, and other part contains all ones in the selected bit, isn't it? So if I choose one bit, I am going to divide the entire space into 2 parts, isn't it? Now in this space also, just check it. If I choose one bit, the first bit, I'll be dividing the entire space into 2 parts. One space will be having zeros in the selected part, and other space will be having ones in the selected part, isn't it? Now if I choose 2 bits, then I'll be dividing the entire space into 4 parts. One space will be having 0 0 in the selected locations, other space will be having 0 1 in the selected location, other space will be having 1 0, and other space will be having 1 1, right? So if I choose 2 bits, I'll be dividing the entire number space into 2 power 2, which is nothing but 4 parts. So similarly, if you have chosen 3 bits, then how many parts would you be dividing the entire number space into? 2 power 3 parts, which is nothing but 8, isn't it? If you have chosen 3 bits, then how many parts would you be actually dividing it? Which means, all the bits are going to be distinct and every number is going to be in a separate part. Therefore you are going to get 2 power 3 parts, which is nothing but 8 parts, right? So one thing you have to note here is, if I have a n bit number, a number is containing n bits, then the total number of bits or numbers present in the number space is 2 power n. So 2 power n numbers will be present in this space, right? And if I choose k bits anywhere, first leading part or any part, if you choose k bits, then you are dividing the entire number system into 2 power k parts, isn't it? So totally there are 2 power n numbers. By choosing k bits, you are dividing it into 2 power k parts. Therefore what is the size of each part? See, we have 2 power k parts which are containing a total of 2 power n numbers, isn't it? Then what will be the size of each part? Each part size will be 2 power n divided by 2 power k, which is nothing but 2 power n minus k. So this is important. Now coming to computer networks, this n bits is nothing but IP address, and the k bits which I choose is nothing but network ID part, and n minus k bits is nothing but host ID part. So if I choose k bits, then I'll be getting 2 power k networks, and size of each network is 2 power n minus k. It can be extended even to operating systems. In operating systems, this n bits is nothing but generally the address of a memory, and the k bits is nothing but the page offset or page number or block number or segment number, and the remaining bits are nothing but page offset or page size, right? And coming to computer organization, this n bits is nothing but the address, and this k bits is nothing but tag or block offset, and this is nothing but block size, and this is nothing but block number. Okay, now coming to this computer networks, we have IP address whose size is 32 bits, right? In computer networks, the IP address is going to be 32 bits. 32 bits, okay. And now these 32 bits, initially what they did, using these 32 bits, we know that the number of IP addresses possible, total number of IP addresses possible is 2 power 32. That is what we know. And now what they thought was, initially when the computer networks was first introduced for ARPANET and other networks, they divided it into static parts like this. They divided this 32 bits into 8 bits of network ID and 24 bits of host ID part. With 8 bits of network ID, how many networks do we get? 2 power 8, which is nothing but 256. And with 24 bits, what is the size of each network is? 2 power 24. 2 power 24 is nothing but 16 million hosts, which means if I use this classification of 8 bits for network ID and 24 bits for host ID, I am going to get roughly 256 networks, and size of each network is going to be 16 million. So 256 is a very small number. In 1980s and 1970s, this 256 number was enough. The reason is computer networks used to be the networks used to be very small. I mean, there used to be very less number of networks. Every college used to be one network, and roughly there are hundreds of networks, even less than hundreds. So initially when they proposed this ARPANET and all, 256 networks was good enough. But if you take today's networks, even in one city, if you take any city like Delhi or Hyderabad or Mumbai, even in one city we are going to have 256 networks. Therefore this is clearly not scalable. So we didn't use this at all. And moreover, if you buy one network of this size, we are going to get 16 million IP addresses, and 16 million IP addresses is too big number. No practical networks other than this NASA and Pentagon have a requirement of 16 million hosts. Therefore this system is not really scalable. That is why they have gone for the next one, is classful number system, classful IP addressing. So we shall discuss about classful now. Let's see how the IP addresses are classified in classful manner. So we know that IP address is a 32-bit number. So let's see. So IP address is nothing but a 32-bit number. 32 bits were there. And in this using 32 bits, what is the total number of addresses we get? The total number of addresses we get using 32 bits is nothing but 2 power 32. So 2 power 32 numbers we get in this, right? So what they did was, instead of dividing it directly into network ID part and host ID part, they used some other way which is actually scalable. So they have chosen the first bit. The first bit has been chosen. If you choose one bit, we have seen this in the previous lecture. If you choose one bit, we are actually dividing the entire IP addresses into two parts. This 2 power 32 numbers will be actually divided into two parts. One part will contain 0 in that first bit, and the other part will contain 1 in the first bit, right? So total numbers were 2 power 32, and I have chosen one bit, because of which we divided the entire numbers into two parts. Then what is the size of first part and what is the size of second part? The size of first part is 2 power 31. The size of second part is 2 power 31. The reason is 2 power 32, when it is divided into half, we are going to get 2 power 31 and 2 power 31, right? And now the second part, the first part has been left out like that, and now they have chosen the second part. If you look at the second part, how many numbers were there in the second part? The total number of numbers present in the second part are 2 power 31, right? And moreover, our IP address was 32 bits, out of which first bit is already chosen. We had 32 bits, out of which first bit is already chosen, and that bit is set as 1, right? And now in the remaining part, the size of this total part is 2 power 31. This one is 2 power 31. So in this 2 power 31 numbers, I am going to choose the second bit. So if I choose the second bit, then I am again dividing the entire entire addresses into two parts. The first part will contain 10 as the leading bit, 10, 10, so on 10, and the second half will contain 11, 11, 11, 11, so on, right? Now the actual size of this entire number space is 2 power 31. I divide into two parts, therefore size of each part is 2 power 30 here, 2 power 30, right? And we don't do anything with the first part, and we take the second part. Now if we take the second part, how many bits? Our IP address is, no, it doesn't change, it is having 32 bits as usual, but then out of which the first two bits are already fixed as 1 1, right? And how many bits are remaining? The number of bits remaining is 30. Therefore the total size of this entire number space is 2 power 30. Okay, now in this 2 power 30, I'll choose the third bit. So first two bits are already fixed, which is 1 1. Now I am choosing one more bit, because of which the third bit, because of which the entire number space is divided into two parts. The first part will contain 110, 110, so on 110, and the second part will contain 111, 111, so on 111. Now what is the size of each part? 2 power 29. Why? Initial size is 2 power 30, out of which I have taken this. Even if you didn't understand this, maybe since we have fixed up 3 bits, how many bits are remaining now? 29 bits. So how many numbers do you get with 29 bits? 2 power 29. Even you could use it that way also. Now I'll not do anything with the first part. I'll choose the second part, this part. And now our IP address is as usual 32 bits. How many bits are there in here? The number of bits in this one is 3 bits, right? So already first 3 bits are fixed as 111. Then how many bits are remaining? 29 bits. Using 29 bits, what is the size of the entire number space? 2 power 29. Now I'll choose the fourth bit. If I choose the fourth bit, then I'm dividing the entire number space into two halves, right? So one half will contain the total number of bits remaining is 29. Therefore the size of this entire number space is 2 power 29. Now the first half is already containing 111. Now I have chosen the fourth bit. The fourth bit could be 0, which means in the first part all the numbers will contain 1110, 1110, right? And in this part all the numbers will contain 1111, 1111, so on 1111, right? Therefore what is the size of this part? Size of this part is 2 power 28 and size of this part is 2 power 28, right? So this is how they classified the entire IP addresses into. Now the first part which starts with 0, they called it as class A, and the second part which starts with 10, they called it as class B, and the third part which starts with 110, they call it as class C, and this one as class D, and this one as class E. Now we shall go into each class one by one and we shall discuss what is about them. But before that I want to discuss one thing. See, now in class A, what is the total number of IP addresses present? That is one question. In class A, the total number of IP addresses present is 2 power 31. In class B, what is the total number of IP addresses present? It is 2 power 30. In class C, what is the total number of IP addresses present? 2 power 29. In class D, it is 2 power 28. That is the first thing you have to remember. So one kind of question is, given any class, what is the total number of IP addresses present? Okay. And now I'll just explain by taking each class one by one about what is the range and all. Okay. So let me take about class A. So I am talking about class A. Okay. Now before going to any further, I want to discuss about how the IP address is represented. IP address can be represented in two ways. One is you can represent it as a 32-bit number, all zeros and ones, that is one way. And second thing is you can convert the entire 32 bits into a decimal number, that will be a very huge number. That is one way. And the third way is you could divide the entire IP address of 32 bits. See, we have IP address of 32 bits. Okay, so we can divide the entire IP address of 32 bits into 4 parts, right, of 8 bits each, 8 8 8 8, and convert these 8 bits into decimal number and then put a dot in the middle. That is called dotted decimal representation. So what is dotted decimal representation is, given the 32-bit number, I am going to divide it into 8 bits, 8 bits, 8 bits, 8 bits. They are called octets. We are going to get 4 octets and take each octet and encode it to decimal and take that decimal number and put the dots in the middle. That is also called as dotted decimal representation, which is the most popular representation. You could use any representation like binary number or decimal number, but then the most popular representation used practically is dotted decimal number system, right, which means we are going to divide it into 8 bits and then we are going to put a dot. Now one interesting point is, one thing is for sure, given a IP address in binary, you could just see that if it is starting with 0, you can say that it is class A. If the binary number is starting with 10, you can say that it is class B. If it is starting with 110, class C, 1110, it is class D. That one you can directly say. But then given a number in dotted decimal number system, how could you find out what is the class to which IP address belongs to? In order to answer that question, it is easier if you take the first octet, first 8 bits, and examine the first bit, isn't it? Because the first octet contains the first bit. Now if it is starting with 0, then it is class A. And one more thing, interesting thing is, these are all called prefix codes. Prefix codes means class A starts with 0, class B starts with 10, class C starts with 110, and class D starts with 1110, and class E starts with 1111, right? So now if you take any prefix of previous class, let us say 0, that will not be a prefix of any of the others, right, which means 0 will not be a valid prefix to any of the other classes. If you take 10, 10 will not be present as a prefix for any of the other classes. Similarly 110 is also not, 1110 is also not. So it is easier to classify the IP addresses into classes this way. Let's talk about class A first. I am just examining class A here. Okay, so you know that class A contains class A is starting with 0 and there are 32 bits. I'll just erase it. I want to talk about class A. Okay, the first point is, number of IP addresses in class A is 2 power 31 IP addresses. Okay, and second point is, they have taken the 32 bits and they divided class A into 2 parts like this. The first bit is going to be 0 as it is, and how many bits are remaining? 7 bits are remaining, right? So they have taken 8 bits as network ID and 24 bits as host ID part, right? And now the first bit is already fixed as 0. Out of 8 bits, first bit is already fixed as 0. Then how many bits are remaining here? 7 bits. So with 7 bits, how many networks of class A are present? With 7 bits, 2 power 7, which is nothing but 128 networks of class A are present, right? And now if you take any network, how many IP addresses are present in one class? It is 2 power 24. 2 power 24 is 16 million. Therefore 16 million IP addresses are present per one network in class A. These two numbers are important, right? So theoretically there are 128 networks of class A, and in each network there are 16 million IP addresses, right? But then practically, let's see the numbers. Okay, now the next question is, if I have these 8 bits, what is the range? So 8 bits are this, 0 followed by 1, 2, 3, 4, 5, 6, 7, right? I am talking about only the first octet. Why am I talking about only first octet is, that is what contains the starting bits. If I know the starting bits, then I can know what is the class it belongs to. Therefore, I am not examining all the octets, I am examining only the first octet. So using the first octet, I want to see what is the range of numbers that can fall in first octet if the network actually belongs to class A, or if the IP address belongs to class A, right? So now 0 and all these 7 bits can be, the starting can be zeros, 0 0 0 0 0 0, right? Therefore the starting network is 0, starting number is 0, and next one is 0 0 0 0 0 0 0 1, therefore the next number is 1, right? And next one is 0 0 0 0 0 1 0, therefore the next number is 2, so on. The last number is 1 1 1 1 1 1 1, 7 ones. 7 ones is nothing but 127. Okay, so remember this: 1 1 is nothing but 1, 2 ones is nothing but 3, 3 ones is nothing but 7, which means if I have only ones, it is nothing but 2 power number of ones minus 1, isn't it? It is 7 because it is 2 power 3 minus 1. If I have n ones, then it is nothing but 2 power n minus 1. If I have 7 ones, it is nothing but 2 power 7 minus 1, which is nothing but 127. Therefore the number of networks are 0 to 127, which is nothing but 128, but we are not going to use 0 and 127. I'll explain you later why we are not going to use 0 and 127 practically. Therefore practically the number of networks present in class A is 126. Even though we got 128, we are not going to use 0 as a valid class A network and 127 as a valid class A network. Therefore even though we have 128 as theoretical number, practical number is going to be 126. So practically 126 networks of class A are present, and in each network we have 16 million IP addresses, right? So this is the range. So now the range of the class A is 1 to 126. Okay, so the range of class A is nothing but 1 to 126. So if you see any IP address in which the starting number is either any of them in 1 to 126, you can say that it is class A network, right? So if you look at class A network, we have observed that there are nearly 2 power 24 IP addresses in class A network, which means 16 million hosts. You can configure 16 million hosts. So generally who will buy this class A network is very big organizations like NASA, Pentagon, such things, right? But small organizations, they cannot afford to buy it. Therefore we go for class B. In class B, they know since it is very big, class A is very big, they solved it into class B. So let's see about what is the range and what are the other things of class B. Coming to class B, again we have the same thing. So one thing is in class B, how many IP addresses are present? 2 power 30 IP addresses are present, and all these 2 power 30 IP addresses have to be divided into networks and hosts, right? So whatever you want to play in class B, you have to play with only 2 power 30 numbers. So the question is how many IP addresses are totally present in class B? It is 2 power 30, and then we are going to divide into networks and hosts, right? So first thing is, if I have a 32-bit number, class B always starts with 10, which means first 2 bits are fixed. You cannot do anything with the first 2 bits. They are already permanently fixed, right? And how they divided the 32 bits is, they divide into 16 bits of network ID and 16 bits of host ID. This is what they divided. Now with using 16 bits of network ID, okay, 16 bits of network ID, we are going to use it. Already first 2 bits are fixed as 10. Then how many bits are remaining? The total number of bits remaining is 14. So how many networks are present in class B? It is 2 power 14, which is nearly equal to 16,000, right? Roughly equal to 16,000 networks. So in class B, number of networks is 16,000, which is 2 power 14. And if you buy any class B network, how many IP addresses you get is 2 power 16 IP addresses are present in one network, right? So totally there are 2 power 14 networks, and each network contains 2 power 16 IP addresses. Therefore total number of IP addresses is 2 power 30. That is what we have. We just divide into networks and hosts, okay? And now I want to see the range. Just by looking at the first 8 bits, I want to find out what is the range of class B. I am not interested in looking at all the 16 bits or 32 bits. I want to see the first octet. So first octet is nothing but just the first 8 bits, right? So first 8 bits are nothing but 10 followed by 1, 2, 3, 4, 5, 6. So this is the first 8 bits, right? Now 10 followed by 6 bits, 0, 0, 0, 0. This is the first number. So what do you get? 128. So the weight of the first, if you have 8 bits and the first bit is 1, the weight of this is 2 power 7, which is nothing but 128. You can convert that binary numbers, okay? That I'll leave it to you as exercise. And the last one is 0. Next one is 0, 0, 0, 0, 0, 1, which is nothing but 129. And 0, 0, 0, 0, 1, 0, which is nothing but 130. So on. The last one is 1, 2, 3, 4, 5, 6. 6 ones. So 6 ones is nothing but 31. Already we have 128 as the weight of the first bit, and there are 6 bits here, so which is 31. So 128 plus 31, which is nothing but 1 second. 6 ones is not 31. 6 ones is 2 power 6 minus 1, which is 63. Therefore 128 plus 63 is 191. Therefore the last one is 191. You need not by heart this range, you can derive it this way. So the range of the practical range of class B is 128 to 191. Now one interesting question is, if you look at the range of class B, you might get confused that I am showing only 128 to 191 numbers, so which is nothing but 64. I am showing you only 64 numbers, but then I am saying that there are nearly 16,000 networks. I am showing you 64 numbers and I am saying that there are 64,000 numbers. How is it possible? Is we got only 64 numbers because we have examined only the first octet of 16 bits. There is one more octet, isn't it? The total network ID part of class B is 16 bits. But then I have shown you only 8 bits here. Using 8 bits I got 64 numbers, and how many bits are remaining? 8 more bits are remaining. Using 8 more bits, how many numbers do I get? Again one more 2 power 8. Therefore using first octet I got 64 numbers, and there is second octet remaining for which I get 2 power 8 numbers. Therefore totally it is 2 power 14 numbers. 2 power 6 into 2 power 8, which is 2 power 14. So even though I am showing you only few numbers, 64 numbers here, they are capable of generating 16,000 networks. If you want to see how they could be generated, maybe you can observe this way. See this? So even though I am showing you only number 128, it is actually equivalent to 128.0, 128.1, 128.2, so on 128.255, which means every number is capable of generating 256 networks, right? We have 64 numbers and every number is capable of generating 256. Therefore total number of networks is 64 into 256, right? If you look at the next one, 129.0, 129.1, so on 129.255. What about the last one? The last one is 191.255, right? Therefore we have 2 power 14 IP addresses. Therefore we have 2 power 14 networks, and each network is containing 2 power 16 IP addresses are present in each network. Okay. So this is about the entire range, and if you have seen the range of class B is 128 to 191. See, the range of class A is 1 to 126. 0 is not used and 127 is not used. Why? We shall see it later. And coming to class B, the range is 128 to 191. Then you could guess what would be the range for class C. Since we are stopping here at 191, the next number is 192, right? Let's see that. Now let's come to this class C. In class C again we have the total number of IP addresses present in class C is, you can clearly see that the total number of IP addresses is 2 power 29 IP addresses are there. Now we are going to take this 2 power 29 IP addresses and we are going to divide it into networks and hosts, right? So how did they do it is, we have 32 bits, and in the 32 bits they are starting with 110, right? They divide it into 24 bits of network ID and 8 bits of host ID, right? So with 24 bits of network ID, already 3 bits are fixed. How many bits are remaining? 21 bits are remaining. Therefore, see, understand this, there are 24 bits of network ID, out of which 3 bits are already fixed. Therefore, how many bits are remaining? 21 bits are remaining. So the total number of networks of class C possible is 2 power 21, which is roughly equivalent to, I think, 2 million, right? Okay, number is not required, it is roughly equal to that number. And if you take any class C network, the number of IP addresses you get in any class C network is 2 power 8, while host ID part is 8 bits. Therefore, the number of IP addresses per one network is 2 power 8 IP addresses per network. If you buy one network, you are going to get this. What about number of IP addresses in one network in class B? It is 16, 2 power 16, which is nothing but 64,000. So who are going to use this class B is, if you have banks like SBI or IRCTC, they are generally going for this class B. Now what about this class C? They are containing roughly 2 power 8 IP addresses, which is nothing but 256 IP addresses. So if you buy a class C network, you are going to get 256 IP addresses. Then who are going to use it is small offices and small colleges like engineering colleges, small universities. Generally engineering colleges, they don't buy any IP addresses like this, but initial use was in universities, they used to buy this class C. Now let's see the range of it just by looking at the first octet. In the first 8 bits, already first 3 bits were fixed as 110. Then how many bits are remaining? 5 bits. 1, 2, 3, 4, 5. Why? Out of 8 bits, 3 bits are fixed, and therefore we have 5 bits remaining. Then 0, 0, 0, 0, 0. Right? What is this? This is 128 and 64, therefore it is going to be 192, right? And next one is 0, 0, 0, 0, 1, so it is going to be 193, so on 1, 2, 3, 4, 5. So this is going to be 5 ones. What is 5 ones? 5 ones is 31. Already you have 191, 192 as the first number, to which 5 ones are added. 5 ones means 31. Therefore, the last number will be 192 plus 31, which is nothing but 223. Therefore, the range is 192 to 223. So, range of class C is how much? 192 to 223, right? Now you should get a doubt. Doubt is, I am showing you only 32 numbers, but then I am telling you that there are nearly 2 power 21 networks. How is it possible? Same way, I have taken only first 8 bits of network ID, and actually there are 16 more bits remaining, right? Using first 8 bits I got 32. Using first 8 bits I got 32 numbers, and how many are remaining now? There are nearly 16 bits are remaining. Therefore we get 2 power this one, which is nothing but 2 power 21, 32 into 2 power 16, right? So if you want to see what they are, the IP addresses will be 192, I am talking about the networks, okay, 192.0.0, 192.0.1, so on 192.0.255, and again 192.1.0, 192.1.1, so on 192.255.255, which means one number actually represents 2 powers 8 into 2 power 8, which is nothing but 2 power 16 numbers. So 32 into 2 power 16, which is nothing but 2 power 21. All the networks are possible. Okay, so this is about class C. Now coming to class D, let's see this class D here. So class A, class B and class C are actually used for the hosts, which means they divided the class A, class B and class D into class C into network ID part and host ID part. But coming to this class D and class E, they didn't divide it into network ID and host ID part. They have just left it like this, which means in class D and class E, we don't have anything called network ID and host ID. The entire IP address is left like this. So how many IP addresses are present in class D? It is nothing but 120 2 power 28. And how many IP addresses are present in class C? It is nothing but 2 power 28. If you want to see the range of class D starts with 1110, and how many bits are remaining? 1 2 3 4, which means 0 0 0 0, right? And what is the last one? 1 1 1 1. Therefore the range of class D is 111 followed by all zeros is 224, plus 224 plus 4 ones is nothing but 15, 239. Therefore the range of class D is 224 to 239. Okay, and the range of class E is, so you can guess, remaining 240 to 255, right? And these two networks are not used for the practical purposes of assigning IP addresses to hosts. They are generally used in class D is used for multicasting and class C is reserved. So the usage of class C is not known, and they say that they are generally using it for military applications. So if you see any range from 224 to 239 or 240 to 255, we are not going to use it. So this is all about all the networks, right? So one thing you have to note is, I am talking about how many IP addresses you will get if you buy one network of either class A or class B or class C. But then even if you have these many IP addresses, it doesn't mean that you can configure these many hosts. So whenever you buy any class, we are not going to use two IP addresses, the first one and the last one. Therefore always the number of hosts that can be configured is two numbers less than the number of IP addresses present. In this case, even though you have number of IP addresses present as 16 million, which means 2 power 24, practically you cannot configure 2 power 24 hosts. You can only configure 2 power 24 minus 2. The reason we shall see later, in the next video. The reason is this, I'll talk about unicasting and broadcasting next. And even here also, even though we have 2 power 16 IP addresses present in network, we are not going to have these many hosts. The number of hosts is going to be 2 power 16 minus 2. And here also, even though we have 256 IP addresses, the number of hosts we could configure is 254 only, right? So in the exam, if the question is how many IP addresses are possible, you go for these numbers. If the question is how many hosts are possible, you have to subtract minus 2. If the question is what is the total number of IP addresses, 2 power 31, 2 power 30, 2 power 29. How many networks? 126 here, why 2 are subtracted, and it is 2 power 14, 2 power 21. And what about D and E? We have only IP addresses there. How many IP addresses are there in class D? 2 power 28. How many IP addresses are there in class C? 2 power 28. Right, and these two are actually disadvantages of class full. The reason is 2 power 28. What is 2 power 28? Nearly 256 million. 256 million IP addresses have been reserved for multicasting, thinking that we are going to use this 256 million groups. But even today, from 1980s to even this day, we have less than 1000 groups, which means we are using less than 1000 numbers of this 256 million addresses which are reserved. That is why this class D is a disadvantage, right? And even class C, we don't know anything about class C, and they say that it is for special purposes. And class D is completely wasted because we don't have these many groups. It is used for multicasting, which is for group emailing or group broadcasting. But we have only 1000 groups, even though we have reserved 256 million. Now I'll show you why we are not going to use two IP addresses in every class, right, in the next example.